In this video, we're showing how to find the eigenvalues for 2 by 2 matrices. And I have 3 examples for you. Let's enter the first example. Go back to the matrix environment, go to Edit, edit 2 by 2, then 5, -1, 3, and 1. Exit the matrix environment, enter the graphing environment, clear what you have, go back to matrix environment, go to math, press determinant, and determinant comes, enter the matrix, subtract x replaces lambda, times matrix, go back to math, enter identity matrix. Matrices this time are 2 by 2, so enter 2, and then graph. I can see there are 2 zeros over here. So I go back to calculator, find the zeros, left bound is good. Let's go to the right bound, and it gives me x equal to 2. Again, calculator, 0, left bound, and the right bound, and it gives me x equal to 4. So there are 2 values that make determinant of a minus xi equal to 0, and those are the eigenvalues of the matrix. And this was very obvious. Now let's try to do the other 2. So first, let's go quit this environment, go back to matrix. I'm going to use matrix B in here, 2 by 2, and I'm putting in -1, 1.5, -1.5, and 2. Then I quit this environment, I go back to Y. Determinant A minus x. Oh, I don't have this matrix in A, I have it in B, so I go to B, minus the x identity 2. Now I graph again. This time around, it seems that 0 is about there. So I go 0, left bound, clear out that area, right bound, clear out this area. Takes a little longer, and it gives me something, and might actually be 0.5, and it might be the calculator error. And so I go back to the table, I enter 0.5, and I get 0. So that was the calculated error in finding the 0. So this one only has x equal to 0.5. Check again. Make sure you kind of want to zoom in sometimes. Make sure that this is the case. So I'm as close as I can get. And then I zoom in. And I see that the graph is actually tangent to x-axis. So x equal to 0.5 is actually root of multiplicity 2 for the polynomial, that the determinant polynomial. How do I know I'm being tangent to x-axis tells me that multiplicity is more than 1, but how do I know it's 2? Again, because this polynomial is of degree only 2, and that makes x equal to 0.5 of multiplicity 2. So let's do the last example. C equal to this matrix. Going back to the matrix environment, edit, and I'm editing C, 2 by 2, 2, negative 5, 1, and 2. And then the next part is to graph this again. So quit the environment, graph. Again, matrix, edit, determinant, matrix, this time C minus X times matrix, identity, and 2. And then we graph. This time the polynomial, the parabola, because this is 2 by 2, degree is 2, the parabola does not touch the x-axis. Therefore, the solutions to this to determinant of a minus xi equal to 0 are only complex numbers. There is a little trick that we can use. If I can find the vertex of the parabola, the x-axis for the vertex of parabola gives me the x value for the vertex of parabola gives me the real part of the complex roots, and then the y value, if I take the square root of the y value, it gives me the absolute value of the imaginary part. So let's try to find the coordinates of the vertex. So calculate value, and I'm plugging in, is that 1? Let's try 1. It came over here, so that's not 1. Go back to calculate value, plug in 2, and this time I see that's the vertex. The values that I'm getting are x equal to 2, y equal to 5. And so from here, what I observe is that the lambdas are going to be like 2 plus minus square root of 5i. And that concludes our lesson for today.